Hello guys, so this is our presentation on Alstom subassembly. So a little bit about company background. Alstom is an innovator in rail transport and sustainable solutions. It's located in West Mifflin, Pennsylvania, about 20 minutes south of Pittsburgh, and they manufacture airport cars for Denver, Miami, Tampa, and Atlanta airports. Our problem statement is that Alstom faces challenges with the proper allocation and arrangement of their workspace, also processing information and material within the subassembly department.
So as far as our approach and methodology goes, we had three different methodologies for our three different deliverables. Our first methodology was systematic layout planning, used for our subassembly layout redesign deliverable. Our second was our 5S improvements, and that was just incorporating general knowledge from our courses in IE, such as productivity analysis, to help Alstom out with 5S improvements. And our last deliverable was our subassembly work schedules, which were created from the interpretation of data that Alstom provided to us in the form of Excel tables that detailed how much time it took to complete various subassemblies.
Our first deliverable is the new layout that we constructed for Alstom. This approach we took followed the systematic layout planning steps in which we first initialized the space requirements. This consisted of identifying and measuring the stations and number of stations needed to complete all desired tasks within the week, like workspace, storage mediums, tooling, and work in progress. From there, we formed relationships, diagramming the importance of station proximity in relation to the flow of materials or information. We were able to combine our findings to form a new layout prioritizing those high-level relations in hope of reducing travel distance and clutter from the original.
Shown in the middle of the poster is our subassembly work schedule deliverable. For this particular example shown is our Atlanta mechanical subassembly work schedule. The way our work schedules were created, and so we included a 1-hour break for every worker every day, and tasks were allocated within the schedule with respect to how much time Alstom approximated that it took according to the Excel data that they provided us. And so with this particular work schedule, there were 2 workers working 40 hours a week, so there were 80 hours available, and it took about 77 hours to complete all the subassemblies, including the 1-hour break for each worker every day. So it worked out quite nicely.
And for the 5S improvements, as can be seen below, we decided to use a clothing pin system that was already being used by Alstom, and we are going to implement green clothing pins for an assembly that would already be done, and red clothing pins for an assembly that's in WIP, work in progress. This would minimize errors committed by the workers, where they would be confusing an assembly to be ready or not, and this would overall cause the process to flow better.
And for the measurement improvement at the right side of our poster, the first thing we use is the efficiency rating comparison. We calculated the original layout scores and the new layout scores, and it shows that we have 49% increasement. And the second measurement is material handling distance. We can see the first three rows has improvement, and the last thing has decreased because of the reallocation of departments, but not increase of the distance.
So the last part is the recommendations. So firstly, we recommend Alstom will take 2 weeks to implement the new work schedule. As we talked before, it's a specific plan on when to assemble each other parts, so the orders will be on time. So next step will be 1 month to implement the new proposed layout, which is greater flow of information and also reallocation of all the desks and shelves. So the last step is take 1 week to take the 5S improvements. So that's all. Thank you.